Good morning, students. This is Narendra Jain, Director, Manthan Career Institute, Director, Parshv International Senior Secondary School. Students, you can see these videos on my YouTube channel, Narendra Jain Sir's Chemistry. So, students, what we are discussing is the preparation of the haloalkane. In the last video, we have done the preparation of haloalkane by halogenation of alkane. Today, we are going to start the second preparation, that is preparation of the haloalkane from alkene, and the reaction is called as hydrohalogenation of the alkene. What do you mean by the word hydrohalogenation? It means addition of HX. HX means halogen acids. For example, it is HCl or HBr or HI. This is called as hydrohalogenation reaction. Now see, students, alkenes are of two types. One is the symmetrical alkene and another is the unsymmetrical alkene. Now the question arises, what do you mean by the word symmetrical alkene? See, those alkene which have same number of hydrogen on the both side of the double bonded carbon. Two hydrogen and two hydrogen are there, which have got the same number of hydrogen on the both side of double bonded. They are symmetrical. This is also symmetrical. CH3, CH double bond, CH, CH2. This is also symmetrical. And see, what is unsymmetrical alkene? Those alkene in which on both sides of the double bond unequal number of the hydrogens are there. This is unsymmetrical alkene. So we discuss addition of the HX on, first we go for the symmetrical alkene. First is addition of HX on symmetrical alkene. Now see, students, when alkene, for example, we have taken ethene, CH2 double bond CH2. This is called as the ethene. Ethene is reacted with HX. HX means HCl. We take the HCl. So, since both of them are what? Equal number of hydrogens are there on the both side of the double bonded carbon. So, this reaction here H plus and Cl minus is there. Remember, student, alkene shows electrophilic addition reaction. Question arises, what does this line mean? Electrophilic addition reaction. Electrophilic addition reaction means in alkene, electrophile will attack first. See, this is the electrophile. What is electrophile? Positively charged species called as electrophile, and the negatively charged species called as the nucleophile. So, in the case of the alkene, as it is going to show the addition reaction, electrophile will attack first. That's the reason why it is called as the electrophilic addition reaction. Now see, HCl is there, H plus and Cl minus both will attack, but first attack of the electrophile will take place. See, this electrophile will attack first. Now the point is that plus always attacks on the minus and the minus attacks on the plus. So it is clear that if this plus has to attack on this alkene, then either of the carbon should have got the negative charge. So this pi electron shifts here. This is the negative, this is the positive. Both are same. You can shift here also, but since H plus is present closer to this carbon, therefore I have shifted the pi electron to this carbon, and the shifting of the pi electron due to the attacking species is called as electromeric effect. So due to the electromeric effect, this plus is going to attack on this carbon and this Cl minus will attack on this carbon. So the final product is, this is your final product, CH2, Cl and CH3. So this is the addition of HCl or HBr or HI on the symmetrical. Remember, student, we are adding the HCl, HBr, HI on the symmetrical alkene. We are not talking for the unsymmetrical. On the symmetrical, no rules. As you wish, shift the H on any of the carbon, shift the Cl on any of the carbon. Now, if we follow addition of HCl or HBr or HI first on unsymmetrical alkene. Unsymmetrical alkene. In the case of the unsymmetrical alkene, if we want to add these compounds, we have to follow the two rules. What is unsymmetrical alkene? Having unequal number of hydrogen on the both side of the double bonded carbon. This is unsymmetrical alkene. If we want that this should undergo addition reaction, then this addition will take place according to two rules. What are the two rules? First is in the 11th class it was studied Markonikov Rule, and the second is the anti-Markonikov rule. We have got the two rules. First is Markonikov and the second is the anti-Markonikov rule. First, we start for the Markonikov rule. What is Markonikov rule? See, according to this rule, I am going to explain in the two ways. First, which is the main explanation. Second, which is written in the your books. According to this rule, what I have told you, in the case of the addition reaction, alkene shows electrophilic addition reaction. Therefore, electrophile will attack first. So, this rule, positive part or H plus or electrophile. एक ही बात है, one and the same thing. Whatever you say, positive part or H plus or electrophile will attack on that carbon of double bond where hydrogen is what I have written more. The positive part or the H plus or the electrophile will go on that carbon of the double bond where hydrogen is already more. This is the Markonikov rule. For example, CH3 CH double bond CH2. This compound is called as propene, and it is clear that unequal number of hydrogens are there, so it is the unsymmetrical alkene. Now we add HCl. Then what I am writing is the MR. MR means Markonikov rule. Then what Markonikov says, double bond will attack on that, so hydrogen will attack on that carbon of the double bond where hydrogen is more. So this hydrogen will go on this carbon and the Cl have to go on this carbon. Okay, plus and minus. This pi bond shift here. This is minus and the plus. So product is CH3, CH, Cl and CH3. The compound is 2-chloropropane. This is clear. This is 2-chloropropane. So this is the Markonikov rule. What is the Markonikov rule? Says electrophile or the positive part or the H plus will go on that carbon of the double bond where hydrogen is already more. Now the reason arises why Markonikov say in this way. We have to see the mechanism. Of this reaction, CH3CH double bond CH2 plus HCl is there. See the final. Whenever you explain the mechanism, remember this point in the board examination. First you write the reaction, then start the mechanism. So H will go here, Cl goes here. The product is Cl and the CH3. This is, and keep in mind, students, what I am doing, whenever you write a reaction, always write the name of the organic compounds, what you are given and what you are preparing. So it is propene is converting into 2-chloropropane. Since in alkene, H plus will attack first. Why? Because I have told you, alkene shows electrophilic addition reaction. So in alkene, H plus will attack first. So this is the propene, CH double bond CH2. This is H plus. What we are doing, H plus will attack. We have got the two possibilities. See students, what we have to decide, why H plus go on this carbon. So in order to decide that H plus will go on the CH2 carbon, we will consider both the possibilities. What are the two possibilities? One is path A and second is path B. What is path A says? If I go send the H plus here, this is path A, then what will happen if H plus goes here? Then CH3, CH, CH3. How it is possible? If pi bond shift here, negative charge, H plus attack, so automatically it will generate the positive charge. This is secondary carbonium ion. Now see, if I take part B, what the path B says, the H plus can go here also. This is only possible when we shift the pi bond. In this case, see students, we are discussing the two paths. One path is the A path and this is the B path. In the case of the B path, what will happen? CH3, hydrogen goes on this carbon, CH2, this is CH2 and the positive. This is primary carbonium ion. And student, in the last video, I have told you about the stability of the intermediates. We all know, since secondary carbonium ion is more stable as compared to primary carbonium ion, therefore it is formed majorly. Remember student, I am not saying that this will never form. It will form in the small quantity, but it is going to form in the major quantity, majorly. That is this point. Now, this is part 1, this is part 2. What will happen? We have make it clear that this is going to form in the major content. So, Cl minus will go now on this carbon. So, the product is CH3, CH2, CH3. This is clear, and Cl is there. Okay. This is 2-chloropropane. Getting this point? So, what happened? Hydrogen goes to that carbon of the double bond where hydrogen is more. Why? Because in that condition, secondary carbonium ion is formed, or we can say more stable carbonium ion is formed. That's the reason why hydrogen goes to that carbon of the double bond where hydrogen is more. It is in accordance to the Markonikov rule. For example, one more addition reaction we take. This is what? See, both double bonded carbon are there. CH3 and H is there. HBr I am going to add. H will go to that carbon of the double bond where hydrogen is more. Here no hydrogen. Here one hydrogen is there. So H will go on this and Br will go on this. The product is CH3. Br has gone on this and this. This is the final product. So this is the addition of the HX on alkene by Markonikov rule. The next topic is addition of HX on alkene by anti-Markonikov addition.